So the quiz that you have tomorrow is on section 6.1 and 6.2. You are stating the domain given rational expressions. You're finding indicated values given rational functions, reducing fractions to their lowest terms, finding the product of your rational expressions, and then finding the quotient of them as well. So we're going to start with finding the domain. If you look at number 1, you're given 5 minus x over 3x minus 3. To find your domain, you're going to take the denominator, set it not equal to 0, solve for what x cannot equal, and then put it into interval notation. So if we look at this, your denominator is that 3x minus 3. We're going to take that 3x minus 3, set it not equal to 0, and solve. First, we're going to move the 3 over by adding it to both sides. We get 3x is not equal to 3. Then we divide each side by the 3 to get that x cannot equal 1. If x cannot equal 1, it will equal every other number from negative infinity to positive infinity except 1. So to give your domain in interval notation, you're going from negative infinity up to positive 1 with a union from positive 1 to positive infinity. For number 2, you're given x minus 4 over x squared minus 25. Again, we're not worrying about the numerator, just the denominator. So we're going to take the x squared minus 25, set it not equal to 0, and solve. You could either factor this to be x minus 5 times x plus 5 is not equal to 0, then set each set of parentheses not equal to 0 and solve them. Or you can move the 25 over by adding it to both sides. That would leave you with x squared is not equal to 25. And then you just take the square root of both sides and remember to put the plus or minus in front of your answer. So x cannot equal plus or minus 5. So to put this in interval notation, you're going from negative infinity up to negative 5 with a union between negative 5 and positive 5 with a union from positive 5 to positive infinity. So number 3, you have x over x squared minus x minus 2. For this one, you're going to set that denominator not equal to 0 and factor it. So x squared minus x minus 2 is not equal to 0. Your factors of negative 2 that add up to be negative 1 are negative 2 and positive 1. So this factors to be x minus 2 times x plus 1 cannot equal 0. So since this is completely factored, we're going to set each part not equal to 0 and solve. So we're going to have x minus 2 is not equal to 0, and x plus 1 is not equal to 0. For the x minus 2 is not equal to 0, add your 2 over. You get that x cannot equal positive 2. For the x plus 1 is not equal to 0, subtract your 1 over. So x cannot equal negative 1. So if you were to graph this on a number line first before you give your interval notation, on your number line, you would go from negative infinity to positive infinity. So your line would literally go over the entire number line. However, you would look for the negative 1 and the positive 2 and erase over the negative 1 and the positive 2. So the only thing you'd have to do is put your parentheses in, and that literally gives you your interval notation, but in number line form. So start from the left and move to the right. You're going all the way from negative infinity up to the negative 1, but you don't include the negative 1 because it's not equal to negative 1. Then you have a union between the negative 1 and the positive 2. Again, parentheses on both of those because it doesn't include both of them. Then you have, lastly, a union between 2 and positive infinity. Then that's when you have more than one of your numbers that x cannot equal. So if you have like that x cannot equal one single number, you're going to have something like number 1, where you just have from negative infinity to a number with a union from that number to positive infinity. If you have that x cannot equal 2 numbers, that's when you're going to have the union between the negative infinity to negative 5, there's negative 5 to positive 5, or the 5 to positive infinity, like if you were looking at number 2. Okay. For number 4, you have 1 over x cubed minus x squared. We're going to take that denominator, x cubed minus x squared, set it not equal to 0. Between these two terms, we have a greatest common factor, which is x squared. So we're going to factor that out first. So we're going to have x squared times x minus 1 is not equal to 0. You're completely factored here, so set each part not equal to 0 and solve them. You have x squared is not equal to 0, and x minus 1 is not equal to 0. For the x squared is not equal to 0, you can just take the square root of both sides, and you get that x cannot equal 0. 0 is neither positive nor negative, which is why we don't put that plus or minus in front of that number. With the x minus 1 is not equal to 0, add your 1 over. You get that x cannot equal 1. So again, if you want to use the number line, you can. On your number line, you'd find the 0 and you find the 1. You're going to draw a line from negative infinity to positive infinity. And then erase right over the 0 and the 1 to not include those. If you plug in your parentheses for these, you're just cutting off those lines where those empty spaces are. Okay? So this gives you from negative infinity up to 0, with a union between 0 and 1, with a union from 1 to positive infinity. For 5 through 8, we're evaluating for each given function. So for 5, we have r of x is equal to 5 minus x over 3x minus 3. We're going to find r of 5 and r of 1. If we find r of 5 first, we're going to plug in 5 anywhere we see the x. So that's going to be 5 minus 5 over 3 times 5 minus 3. Up top, that 5 minus 5 is 0. Over the bottom, which is 15 minus 3, gives us 0 over 12, which is just 0. So r of 5 is equal to 0. If we find r of 1, again, we're going to plug in 1 anywhere we see the x. So that's going to be 5 minus 1 over 3 times 1 minus 3. Your 5 minus 1 gives you 4. Over the 3 times 1 is 3, minus 3 is going to give you 4 over 0. Anytime you have 0 in your denominator, it's undefined. So r of 1 is undefined. If we look at number 6, we're given t of x is equal to x minus 4 over x squared minus 25. If we first find t of 4, we're going to have 4 minus 4 over 4 squared minus 25. That 4 minus 4 gives you 0. The 4 squared is 16 minus 25. Either way, you have 0 on the top, so it's automatically going to be 0. So t of 4 is 0. If we do t of negative 5, we're going to have negative 5 minus 4 over negative 5 squared minus 25. This gives us negative 9 over 25 minus 25. This simplifies to be negative 9 over 0. 0 in the denominator gives you that t of negative 5 is undefined. For number 7, you have h of x is equal to x over x squared minus x minus 2. You're finding h of negative 2 and h of negative 1. So first, if we find h of negative 2, we're going to have negative 2 over negative 2 squared minus negative 2 minus 2. That negative 2 stays up top. On the bottom, that negative 2 squared is going to be 4 plus 2 minus 2. The plus 2 minus 2 are opposites, so they'll cancel. And that's left, or that's leaving you with negative 2 over 4, which gives you h of negative 2 is equal to negative 1/2. for h of negative 1. This is going to give us negative 1 over negative 1 squared minus negative 1 minus 2. So it's leaving you with negative 1 over 1 plus 1 minus 2. 1 plus 1 is 2, so that's negative 1 over 2 minus 2, which is negative 1 over 0. Anything with 0 in the denominator means it's undefined, so h of negative 1 is equal to undefined. For number h, you have g of x is equal to 1 over x cubed minus x squared. You're finding g of 0 and g of negative 1. If we first find g of 0, this is going to give us 1 over 0 cubed minus 0 squared. 0 cubed and 0 squared is just 0, and 0 minus 0 is 0, so it's 1 over 0. Again, 0 in the denominator means undefined, so g of 0 is undefined. To find g of negative 1, we're going to have 1 over negative 1 cubed minus negative 1 squared. That negative 1 cubed is negative 1. The 1 squared is 1. Negative 1 minus 1 gives us 1 over negative 2. So g of negative 1 is negative 1/2. For the next set of questions, we are just simplifying. So for 9, we have a cubed b c cubed all over a to the 5th power b squared c. If you wanted to separate these to be a cubed over a to the 5th power times b over b squared times c cubed over c, you could do that and then just simplify. Or you can use your rules of exponents and say if your base is the same on the top and the bottom, you're going to subtract their powers. So that means that you're going to have a to the 3rd power minus the 5th power, b to the 1st power minus the 2nd power, and c to the 3rd power minus the 1st power. This will leave you with a to the negative 2nd power, b to the negative 1st power, c to the 2nd power. Your a to the negative 2nd is going to go down. Your b to the negative 1st is going to go down. So that c squared is left on top, and then you have a squared b on the bottom. For number 10, you have x to the 4th power minus 1 over 3x squared minus 3. You got to factor both the numerator and the denominator in order to simplify this at all. The top is going to factor because it's a difference of squares to be x squared minus 1 times x squared plus 1. The bottom, you have a greatest common factor of that 3, so you factor that out first to give you 3 times x squared minus 1. You can continue to factor the x squared minus 1 on both the top and the bottom. However, it is on the top and the bottom of your fraction, so you know that it's the same exact thing, and they will cancel each other out. So if you do cancel these two out from here, you're going to be left with x squared plus 1 all over 3. You cannot factor the x squared plus 1 because it's not a difference of squares, it's a sum of squares, and that's not factorable. So this is your answer. When you see these questions on your quiz tomorrow, it's going to tell you to simplify each rational expression, write your answer in factored form. So you do not have to multiply these out. So if you're left with something like x minus 1 times x plus 3 all over 4, then you don't have to multiply out the numerator. You can leave it as its factored form. For number 11, we have 68x cubed all over 51xy. The 68 and the 51, you can simplify those if you can. The 68, I'm not sure. Hold on one second. So 17 goes into both the 68 and the 51. The 68 divided by 17 is 4. So this becomes 4 over the 51 divided by 17 is 3. So this is 4, this is 3. You have an x cubed on the top you have an x on the bottom. So that 1 on the bottom is going to cancel out, and you're going to subtract the power from the top's power, which is 1. So that gives you x squared. The y on the bottom is going to stay on the bottom. So that's just 4x squared over 3y. For number 12, you have 5x squared minus 15x plus 10 all over 5x minus 10. You have a greatest common factor on both the top and the bottom that you can factor out. So on the top, your greatest common factor is 5. That's going to leave you with 5 times x squared minus 3x plus 2. On the bottom, your greatest common factor again is 5, so that's 5 times x minus 2. Those 5s can cancel each other out, so if you'd like to do that now, you can. From here, you got to factor that trinomial up top. Your factors of positive 2 that add up to be negative 3 are negative 2 and negative 1. So this factors to be x minus 2 times x minus 1 all over x minus 2. You have an x minus 2 on the top and the bottom, so they cancel. The bottom just leaves you with 1. So you have x minus 1 over 1, which is just x minus 1. For 13 and 14, we're finding the product of these rational expressions. For 13, you have a cubed b squared over b cubed a times ab minus b squared over ab minus a squared. If you would like to, we can factor the ab minus b squared and the ab minus a squared. You have greatest common factors in both of them, so you can factor that out. This is going to leave you with a cubed b squared over b cubed a. If you wanted to rewrite that to where it's a b cubed, you can do that also. Times, up top, your greatest common factor is b, so it's b times a minus b. On the bottom, your greatest common factor is a, so that's a times b minus a. If we rewrite the denominator in that second fraction as negative a plus b, we can actually factor out a negative 1 as well to turn this into the opposite of a plus b, so the negative times a minus b. So your greatest common factor that you would have factored out there is a negative a. So this just gets rewritten to where you have a cubed b squared over a b cubed times b times a minus b over negative a times a minus b. If you wanted to simplify before you multiply, you can do so. If not, you can just multiply straight across and then simplify. If I multiply straight across first, this is going to give me a cubed b cubed times a minus b all over negative a squared b cubed all over a minus b. Ask yourself first, what is the same on both the top and the bottom of this fraction? You have an a minus b on the top and the bottom, so they cancel. You have a b cubed on the top and the bottom, so they cancel. You have an a cubed and a b squared on the top and the bottom of this fraction. So we can take 2 away from that 3, so that's going to give us just a over negative 1, which simplifies to be negative a. And again, you don't need to multiply that out because your directions tomorrow will tell you to keep your answer in factored form. So that is factored form. For 16, we have x cubed minus xy squared all over y divided by x cubed plus 2x squared y plus xy squared over 3y. I'm going to keep change flip first, It's going to give us x cubed minus xy squared all over y times 3y over x cubed plus 2x squared y plus xy squared. From here, on the top of my first fraction, I can factor out the greatest common factor, which is x, so that's going to be x times x squared minus y squared. It's going to stay over y. My second fraction, I have a greatest common factor on that denominator as x as well, so that's going to become x times x squared plus 2xy plus y squared. We can still factor the x squared minus y squared because it's a difference of squared. We can also factor the x squared plus 2xy plus y squared because it's a perfect square trinomial. So this is going to factor further to be x times x minus y times x plus y all over y times 3y over x times x plus y times x plus y. From here, if you want to simplify diagonally or within the same fraction, you can try to do that. If not, you can multiply straight across. If you multiply straight across, you're going to have 3xy times x minus y times x plus y all over xy times x plus y times x plus y. On the top and the bottom of this fraction, you have an x plus y. You also have a y. You also have an x. So this is going to leave you with 3 times x minus y over x plus y.